Hello, thank you for watching this video. So in this video we do question 9 of May June 2022 question paper mathematics paper 2. And the topic is Euclidean geometry, as you can see. So I'm going to read question 9 statement and then answer the questions that follow. So let's go. They are saying in the diagram, DEFG is a cyclic quadrilateral with DE parallel to GF. They are saying DE is reduced to R, T is another point on the circle. EG, FT, and ET are drawn. You are told that angle E4 is equal to 72 degrees and angle G1 is equal to 16 degrees. So, this is what you can see here. So, you can see the circle over here. So, you're told that DEFG is a cyclic quadrilateral. If you don't know what a cyclic quadrilateral is, go to my playlist and watch bad actions. You will know what cyclic quadrilaterals are. I did teach those in detail. Hopefully you will find the videos, but they are up there. So they wanted to say that your DE is parallel to GF and T is another point on the circumference. You can see point T is also on the circumference of this circle. They say some lines are drawn and they told you that angle G1 is equal to 16 degrees and angle E4 is equal to 72 degrees. No problem. What are they saying? They are saying determine with reasons the size of the following angles. So they want us to find the size of the following angle. At 9.1.1, they want you to find the size of angle G, which is the angle that is formed by DG and GF. So they want you to find the size of angle G. This angle G is formed by DG and GF. Where is DG? DG is this line here, and GF is that line over there. So they want to find the size of this entire angle here, which is, let me try to find another ink. So they want to find the size of this entire angle over here, because we're saying it's angle G, right? Your angle G is formed by DG and GF. DG is this line and GF is that line over there. So which means they want to find the size of the angle. Fine. So if you have watched it or you know cyclic quadrilaterals, you will know that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So that is an outside angle of a cyclic quadrilateral. It's going to be equal to the interior opposite angle. So if you can watch my bad actions, you'll understand what I'm talking about. So in this case, this angle E4 is equal to this angle, this entire angle here, which is DGF. So our angle, angle G is equal to angle E4 is equal to E4. So this angle, which is this entire angle here, this angle over here, is equal to that angle. This angle is an exterior angle of a cyclic quadrilateral. An exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So this angle E4 is equal to this angle over here. So in that case, which is equal to 72 degrees, right? The reason for that is because this is an exterior angle of a cyclic quadrilateral. Cyclic quad. That's it. Now we'll move to the next one, which is 9.1.2. What are we going to do? Let's put that information here. So the entire angle is 72 degrees, same as that one. Now we move to 9.1.2. They say determine with reasons the size of angle T. So they want us to find the size of angle T. Where is angle T? Angle T is this angle over here. So how do we find this angle over here? So if you look at the angle T, this angle T is formed by EF, or you can say subtended by EF, this angle T, right? No problem. But if you look at your EF also formed angle G2 over here. So EF forms angle G2 and also forms angle T. So this angle G2 and angle T, they are equal because those are angles in the same segment, which is those are angles that are subtended by the same chord or are subtended in the same segment. So in that case, what do? We need to know what G2 is. Whatever the value of G2 is, which is this angle over here, we'll be able to find T because those are angles that are subtended by the same chord. So they should be equal, right? So in that case, we need to go and find G2. We can say now, our angle G, right, which is angle G, which is formed by DG and FG and GF, is equal to what? Is equal to G2 plus G1. Right? So this entire angle, which is your angle G, which is formed by DG and GF, is equal to the sum of these two smaller angles here, which is G2 and G1, by the diagram, of course. So in that case, we know what this angle is. This angle is what? This angle we just found it to be 72 degrees, right? G1, we're given G1, and G1 is given to be 16 degrees, plus your G2, which is what you're trying to find. So you find that your angle G2 is equal to the difference between these two. So you say 72 minus 16, that is 56. So you get that your angle G2 is equal to 56 degrees, right? So we get that this angle over here is 56 degrees. The smaller angle over here is 56 degrees. This angle is 56 degrees. The angle over here is 56 degrees. So if you look at this 56 degrees, your 56 degrees is formed by EF, and your EF also forms angle T. So angle G2 and angle T are going to be equal because those are angles in the same segment, which is those are angles that are subtended by the same chord or the same arc, which is EF in this case. So what we'll say, okay, our angle T is equal to angle G2, and they're both equal to what? It's equal to 56 degrees. The reason, say angles in the same segment, which is those are angles that are subtended by the same chord or by the same arc. And we're done with this one. We move to 9.1.3. 9.1.3. And in that case, we can put that information over here and say we have our 56 degrees over here. Move to the next one. So, at 9.1.3, they are saying determine, giving reasons, the size of angle E, which is the angle formed by line segment GE and EF. So, they want you to find angle E, right? They want us to find angle E, which is the angle formed by line segment GE and EF. This is the angle that they're looking for. Angle E is formed by GE, and EF. So we want to find this angle over here. This angle over here. Because look, it's GE and EF. GE and EF. So that's the angle that they want. Angle E, the angle formed by GE and EF. So how do we get this? Look, if we add E1 and this angle that we want, which is angle E, right, and E4, that will give you 180 degrees because these are angles on a straight line, right? So what we're going to do is say, okay, this angle plus that angle is 180 degrees because those are angles on a straight line. Let's write that. We can say E1, angle E1 plus angle E, which is our angle which is formed by line segment with GE and EF, plus angle E4 is equal to 180 degrees. So those are angles on a straight line, right? So our E1, do we have E1? No, we do not have E1. This angle over here, right? We don't have E1, which is this angle over here. But we can find it. How? Because look, if you look at this angle, it's formed between this line and the parallel line, right? So this angle and this angle are going to be equal because these are alternate angles. So this is also equal to 56 degrees. Because you look at this, these are alternate angles. So this angle 56 here and that angle over here are alternate angles on parallel lines. So they are going to be equal. So what we'll say our E1, angle E1 is equal to our angle G2, and they are both equal to 56 degrees. Our reason, we saw these are alternate angles, right, on parallel lines because our DE is parallel to GF. That's where we are. So this is 56 degrees. So in this case, we do have this angle, we don't have this angle, this is what we want, and we have that one. So we can find the angle that we're interested in. So our E1 is equal to 56 degrees plus our angle of interest, which is angle E, plus E4, which is our E4 is given to be 72 degrees. So that adds up to 180 degrees. So you can solve for this now. So G F is equal to 180 minus 56 minus 72. So the answer of that would be angle E of interest. So let's try to find that. We say 180 degrees minus 56 minus 72. So you get that your angle E is equal to 52 degrees. So that's what we are. So this angle over here, this entire angle is equal to 52 degrees. And we're done with 9.1. So I'm going to clean the board, draw 9.2 diagram, and we're going to do 9.2. So let's clean the board and do 9.2. Okay, so now we're doing 9.2. So at 9.2 that side, in the diagram, the diagonals of a parallelogram KLMN intersected P. NM is produced to S. R is a point on KL, and RS cuts PL at T. They are saying the ratio of NM to MS is 1:4, or is 4:1. NL is equal to 32 units, and TL is equal to 12 units. So let's come to this. They are saying in this diagram, we have this parallelogram, which is KLMN, right? And the diagonals of your parallelogram, they intersect here at point P, right? That's saying that your point, your MN, this line MN of yours, is extended. You can see MN is one side of this parallelogram. So MN is one side of this parallelogram. This MN is extended to point S over there, right? That's saying R is a point on KL. There is R, there is KL. So R is a point that lies on your line KL. That's saying RS cuts PL at T. So the line RS cuts PL, which is this line PL at point T over there. They went on to say that the ratio of NM to MS, right, is 4:1, right? Which essentially means your NM over MS is equal to 4/1. So the question that I want to highlight. So if the ratio of your NM to MS is 4/1, does that mean the length of MN is 4? Does that mean your length of MS is 1? No. So this is not necessarily. It can be 4, it can be 1. So those lengths can be 4 and 1, but not in general, right? So to be safe, just think of them this way. Think of them as 4A over 1A. So what does this mean? It means that you might have had your length to be 4 times whatever number that is. So you can say that maybe your A is a positive real number, right? You could have had your A as your positive real number, which is the same for both of them. And then when you took the ratios of those lengths, those A's, they cancelled out, right? So you got the simplest ratio to be this. For example, you can think of this maybe. Let's say your length of MN was 8 and that of MS was 2. So this will come out to be 4/1. So, which means in that case, your A would be 2. But you don't have to worry about that. Don't worry about this. So, I always think of it this way, that this is the simplest ratio, right? So, it was simplified from whatever values that you're taking ratio of, and it came down to this. So in that case, if you're saying the ratio of NM to MS is equal to 4/1, which means this length over here was 4a, which is 4, was whatever have whatever length that you were given. And this one over here is 1a over here. So which is your ms. That's how I look at it. That's how I think of it. And then they want them to say that your NL is equal to 32 units. NL is equal to 32 units, which is your entire diagonal here. This diagonal is equal to 32 units. 32. The entire length of this diagonal is equal to 32. And they want them to say TL is equal to 12 units. TL, which is the length from here to there, is 12 units. Fine. I could work with this. So, at 9.2.1, what are they saying? At 9.2.1. At 9.2.1, they're saying determine with reasons the value of the ratio of NP to PT in its simplest form. So, they want you to find the ratio of NP to PT. They want this ratio. Where is NP? Let's go and highlight NP. NP is this length from N to the midpoint, or to where your diagonals intersect, right? Which is the midpoint of this diagonal. And PT is this distance over here. No problem. So we need to find the length of NP and find that of PT and take the ratio of the two, right? No problem. So we know that the length of NL is equal to 32 units. This was given information, right? So what we can say is that we know that our NP, which is the distance from N to the midpoint, N to P, which is the midpoint, is equal to that distance from this to there, because the diagonals of a parallelogram, the diagonals of parallelogram, they meet at the midpoint, which means this is the midpoint and this is the midpoint of this diagonal. So P is the midpoint of this diagonal NL, and also the midpoint of that diagonal KM. So in that case, your NP, which is this distance over here, is equal to PL. And it's halfway through. If this is 32, that would mean this is 16 units and that is 16 units. So these are 16 units, both of them. We can say these are diagonals of a parallelogram, right? So we know that this length over here is 16 units, and that length over to this point and that length over there is 16 units, right? No problem. But so we have NP to be 16, but we do not have PT. So PT is this distance over here. So we know from L to P is equal to 16, and we know from L to T is equal to 12 units. The 12 units that were given, right? Equal to this 12 units that were given here. So we can say our PL with that diagram. So the distance from P to L, which is this distance over here, is equal to PT plus TL. PL you know because it's from the center to that to the corner of this, to the vertex of this parallelogram. It's called 16 units. We're not given, but we found it out up here, right? So we have 16 here is equal to PT, which is what we're interested in, because you want to take the ratio of the length of NP to that of PT, plus TL, the length of TL. The length of TL you're given to be 12, so it's equal to 12. So if you solve for your PT is equal to 16 minus 12, which is about 4 units. So if you want the ratio of NP to PT, say NP over PT is equal to the length of NP, which is equal to 16, over PT. What is the length of PT? PT is equal to 4. So this is equal to 4 over 1. Therefore, the ratio of NP to that of PT is equal to 4 is to 1. This is your ratio. So, like I said, when I was talking here, do you see that this is the simplest ratio? So just because this is 4 does not necessarily mean the length of NP is 4. And this is because it's 1 does not necessarily mean the length of PT was 1. So PT was this and this was that. But it's simplified. So which means in that case, you had, it's more like your A, if you think about your A, it's 4 here and it's 4 there. Because 4 times 1 to be 16, 4 times 1 to be 4. So that's what I was trying to explain there. So in that case, in that case, we can say this is maybe let's say we say 4b over your 1b. Then I'll put it here. Say this is your 4b, this is your 1b. No problem. So we continue to 9.2.2. At 9.2.2, they're saying prove with reasons that Km is parallel to Rs. So they want us to prove with reasons, right? That Km is parallel to Rs. Where is Km? Km is this line over here. They're saying it's parallel to Rs, right? No problem. So to do this is what you need to remember. You need to remember the converse of the proportionality theorem. They're saying, the converse says, if you have your triangle like this, right? And there's a line that joins two sides of your triangle, right? Let's say this is A, B, C, D, and E. You need to remember the converse of the proportionality theorem. If you have a triangle ABC and you have a line DE that joins two sides of a triangle, such that DE divides the two sides of your triangle proportionally or at the same ratios, then what that tells you, it will tell you that it means your DE is parallel to BC. Let me repeat this thing again. They're saying that if you have a triangle ABC with DE dividing two sides of your triangle at equal ratios or at equal proportions, what does that mean? It means that your DE will be parallel to BC, or your DE is parallel to DC. So let me use the red ink for the parallelness. So in this case, what that means is that if your AD over DB is equal to what? Is equal to AE over EC. What that means is that then your DE will be parallel to BC. So this does not necessarily work for this ratio only. Then it will work for the reciprocal of this as well, which is your DB over AD is equal to EC over AE. Or maybe your AB over DB is equal to your AC over EC, or your BD over BA is equal to CE over AC, as long as you take the ratios of the same parts, right? So if the ratios of the same parts come out to be equal, then that means these two lines are parallel. So they want us to prove that Km is parallel to Rs. Where is Km? Km is this line over here, and this is this line over here. So look at this triangle, at these two triangles, which is NPM and NTS. Look at this triangle, NPM and NTS. Look, if you take the ratio NP, your NP over PT, it came out to be 4 over 1. Your NP over PT came out to be 4 over 1. Look at your NM over MS. You are given to be 4 over 1 as well. So this line, PM, right, of this triangle, of this bigger triangle, because you can see the bigger triangle NTS is divided by PM proportionally, because this ratio of this top over that is equal to this part over that. right? That means now, if you have the situation, that would mean this and that are parallel, and so will those two. So in that case, to write this down, I will say your NM over MS is equal to 4 over 1, which is the same, because this was given. And then we can say our NP over PT is equal to 4 over 1 as well. We found this at 9.1.1 or maybe 9.2.1. Therefore, the ratio of NM to MS is the same as that of NP to PT, right? Because you can see they're equal, right? So what does that tell us? This tells us that this is parallel to that, which means your PS is parallel. Your PS is parallel to TS. Why? Because of the converse of the proportionality theorem. Because of the converse of the proportionality theorem, this line over here is parallel to this line. I'm looking at this triangle over here. And then this triangle of ours is divided by this line proportionally, which is the ratio of the top side to the bottom side, top side to the bottom side. They're equal, they're both 4 over 1. So which means this is parallel to that. And if this line is, if this portion of the line is parallel to that portion of the line, which is this entire line is parallel to that one, right? So we can say therefore your Km is parallel to Rs, because these two are extension of those, so they will also maintain the same orientation. And we're done with 9.2.2. We're going to move to 9.2.3. They're saying if Nm is equal to 21 units, determine giving reasons the length of RL. So you are given that Nm, which is this length over here, you're told that your Nm, which is equal to 21 units, right? So they want us to find RL. So they want us to find this length over here, RL. So RL, if you look at RL lies on triangle LRT, right? So you can see, we said that these two lines are parallel, right? So which means, let me just put these lines as well. So you can see this triangle, you have a triangle RLKP. You can see this LKP is divided by RT here, right? And these two lines are parallel. So we can apply the proportionality theorem itself there. So we can say in triangle, so this is 9.2.3. In triangle LRT and triangle LKP, right? These two triangles, which is LRT and LKP, right? We can say our RL over, which is our RL over here, over the entire side, which is LK. Our LK, which is, I said, this part over the entire side is equal to this part, which is LT. LT over LP. So I said this side over this one is equal to this side over this one, the small one over here. Oh no, the small one, which is the entire side. I said LR over LK is equal to LT over LP, which is the entire side. The reason I'm applying this is the proportionality theorem, this one. Why are we applying the proportionality theorem? Because this line is parallel to this one. Because it only works if you have a triangle and it's divided by side, one side. That is, if you have a triangle, the proportionality theorem works if you have this triangle here that is divided by a side that will be parallel to the third side. So you have triangle LKP, and your triangle is divided by your RT, right? And your RT is parallel to the third side, so it will divide the two other sides proportionally. So what will happen, we're using the proportionality theorem because our KM is parallel to RS, right? And in that case, LR is what we're looking for. LK, do we have LK? LK. LK is this length over here. So we do have this length because we're given that this one is 21. So this is equal to that one. Because these are opposite sides of a parallelogram. And we have this one to be 16. And this one is 12. This one is 12 here. And this one we found it to be 4 PT. We didn't find PT to be 4 units. So in that case, we will say our LK is equal to NM, which is equal to 21. These are opposite sides of a parallelogram, right? No problem. So let's substitute now. Our RL is what we're looking for. RL over LK. Our LK is the entire side, which is 21 units. Is equal to LT. LT is this length over here, which is 12. 12 over the entire side LP, which is 16. Therefore, your RL is equal to 21 times 12 all over 16. What is 21 times 12 all over 16? 21 times 12 all over 16. 63 over 4. The final answer is 63 over 4, which is equal to 15.75 units. So that's the size of side LR. And I think this marks the end of question 9. And I hope it does make sense to you as it does to me. So I'm going to move to the next question, which is question 10. Thank you for watching. Cheers.